Hey, we just learned a whole lot about chemical bonding. I want you to have those notes open. We're going to do a quick bit of review just to make sure that you remember those things. So this is a very active video. Have a pencil and paper handy, and I want you to have yesterday's notes ready. So there were two types of chemical bonding that I taught you about. I want you to pause this video, and if you have to, go look those up in your notes so that you can answer this first review question. Go ahead and pause in 3, 2, 1. Okay, you paused the video. You found the answers and wrote them down. The two types of chemical bonding are covalent and ionic bonding. Why do elements bond? What's the name of the rule? There was a reason why chemical atoms bond to other atoms. Again, if you need to look in your notes, go ahead and pause the video again in 3, 2, 1. Okay, elements bond because they're trying to become like the noble gases. The noble gases have a full valence shell of electrons, and other elements bond together so that they can get that full valence shell. Okay. So I'll write that down quick, and there's a name for the rule for that, and that rule was called the octet rule. Very, very important. Just so you know, and a review here again, the full valence shell is something that elements quote-unquote want because that's a more stable configuration for the electrons. Okay. Number 3, in which type of bondings do atoms share valence electrons? One of them is about sharing. Which one is it? Go ahead and pause in 3, 2, 1. Okay, the type of bonding where they share is covalent. Covalent means shared valence. Item number 4, in which type of bonding does one atom donate to another atom that accepts an electron? So this is the other type of bonding. I'm not going to make you pause for this one. If you've been paying attention, that one's pretty obvious. That's ionic bonding. It's called ionic, by the way, because when one atom donates to another atom, that makes those two atoms into ions. We're going to talk more about ions later in this unit. And question number 5, let's do some Lewis structures showing covalent bonding. I've done the first one for you, okay? It helps if you have a couple of different colored pencils or pens, but it's not mandatory. So this is the covalent bond between fluorine atoms. And what I did on here was I looked up fluorine on the periodic table and I saw that it's in group 17. Now since it's in group 17, that means each fluorine atom gets 7 dots. Okay, so on this one, 1, 2, 3, 4, 5, 6, 7. And then the other one also gets 7 dots. And then to do the drawing, you just kind of draw them nice and close to each other so you can see right here there's a pair of electrons that's getting shared. I want you to go ahead and try to do the same thing for chlorine. Chlorine is right underneath fluorine. It's also in group 17. Just draw the dots and the circles to show the sharing, just like I did. Go ahead and pause your video in 3, 2, 1. Okay, I expect that you've put the dots in here, so I'm just showing you the answer so you can check your work. Here's 7 dots for this chlorine atom. Actually, that last one I'm going to draw right in the middle. And then this chlorine atom also has 7. 5, 6, 7. I can draw the overlapping rings, but let's just take a look at this. This looks pretty nice the way it is, just so you know. These rings right here are not mandatory in your drawings. I've just been putting them in there so that we can see very clearly that there is a pair being shared in the middle. That's the covalent bond between the two chlorine atoms. Let's try another one. This is oxygen. We did this exact same one in our notes yesterday, and this one's a little bit different. It's in group 16, so each oxygen has 6 valence electrons, and the octet rule says that each oxygen then needs 2 more electrons to get a full valence shell, because it's trying to get to 8. From 6 to 8 is 2 more. Chlorine only needed 1 more, right? And since it only needed 1 more, each chlorine atom contributed 1 to the sharing, but now oxygen needs 2 more, so each oxygen atom is going to need to contribute 2 electrons to the sharing. Go ahead and try this one yourself. Pause the video in 3, 2, 1. Okay, here come the answers to this. It's okay if you don't get this perfect. The main thing is that you draw 2 electrons from this oxygen atom in the center, and then the other 4 more, right? 1, 2, 3, 4. These 4 can go anywhere you want around the back side of that oxygen atom. So those aren't important, but these 2 in the middle, it's important that there are 2 in the middle, because again, oxygen needs to share 2 in order to get its octet rule satisfied. And now the other atom, I'm drawing those electrons in red. Again, this one shares 2. And I'm going to draw the overlap just to make sure it's obvious, right? We've got 1, 2, 3, 4, 5, 6, 7, 8 electrons inside of the right-hand oxygen atom's ring, and the left-hand oxygen atom's ring also includes 8 atoms. So both oxygen atoms are feeling that full valence shell, and that's what we want. Okay. So this is a Lewis dot structure for an oxygen molecule. A little bit of fast forwarding here. We're going to get to formulas pretty soon. This molecule right here has a formula of F with a subscript 2, because there's 2 F's. This one is Cl2. I bet you can guess what the oxygen molecule's formula is as well. O2. This is the formula, by the way, for the oxygen that you breathe in the air. It's not just O, it's O2, because if oxygen atoms pair up, they get their octet rule satisfied. Now these ones are ionic bonds, and you can see the drawing is a little bit different. Up above, we had this sharing going on in the middle. That's covalent, but ionic isn't sharing. It's donating and accepting. So here's an example of sodium. Sodium is in group 1, so I drew it with 1 dot. Fluorine is in group 17, so I drew it with 7 dots. Okay. Now again, with the octet rule, fluorine has 7 valence electrons. Octet rule says it wants 8. It needs 1 more. Well, sodium has 1 valence electron, so sodium will donate that valence electron to fluorine. And this is how you show that in the drawing. You draw the 2 atoms separately, and then you put this arrow there to show sodium donating its 1 valence electron to fluorine. You try the same thing here with sodium and chlorine. I haven't put any of the dots or the arrows in there for you. I want you to try that one. Go ahead and pause the video in 3, 2, 1. Okay, you've had a chance to try this out. Again, sodium has 1 valence electron because it is in group 1 on the periodic table. It has 1 valence. Chlorine, just like fluorine, is in group 17. It's a halogen. Group 17 means 7 valence electrons. 6, 7. It wishes it had 1 more. Here it is from sodium, so you start the arrow at that 1 electron and you put it right there in that spot where it would go on chlorine, and that is the whole drawing. That's it. Letter C, very similar, except magnesium now is in group 2. Magnesium has 2 valence electrons. so it wants to donate 2. Oxygen has 6 valence electrons because it's in group 16. So to get to 8, octet rule, it needs 2 more. 6 valence, 7, 8, 2 more. Go ahead and try and draw a picture of this. We did this one yesterday in our notes if you need to look. Pause in 3, 2, 1. Okay, here's what that one looks like. Here are magnesium's 2 valence electrons. Oxygen has 6 valence electrons. That means there's 2 spaces, right here and here, for oxygen to fill. It's trying to get 2 more electrons. So you draw an arrow from 1 electron into that first space, and then you draw an arrow from that electron into that next space. And that is the Lewis dot structure for magnesium oxide. Just for fun, formulas on these ones. This is NaF, pronounced sodium fluoride. This is NaCl, this is pronounced sodium chloride. And this is MgO, pronounced magnesium oxide. Good review, everybody.